Hi everyone, let's solve the first question from today's weekly contest, that is count distinct numbers on board. You are given a positive integer n that is initially placed on a board. Every day for 10 raised power 9 days, you perform the following procedure. For each number x present on the board, find all numbers between 1 to n, right, such that x modulo I should be 1, right? If you divide x by any of the I present between 1 to n, you should get a modulo 1, and then place those numbers on the board and return the number of distinct integers present on the board after 10 raised power 9 days have elapsed, right? Okay, so let's see what the question is. So let's take n is equal to 5 here, right? So if we have n is equal to 5 here, so we have a board, right? So we have to place 5 like it is already present on the board. Now from here we will start our procedure, right? So on the first day we only have 5 on the board, right? So we will take 5 and we have to consider i's between 1 to n for each and every time, right? So I will belong to 1 2 3 4 and 5. I will be belonging here, right? What operation do we have to perform? We have to check for each and every number present. Right now it's only 5, so this should be equal to 1, right? If we divide 5 by any of these i's, it should be 1, and all these numbers we have to place on the board, right? So let's see which I will give us 1 as a remainder on dividing, right? So if we check for 1, we will not be getting, we will be getting 0, right? If we check for 2, so we will be getting 1 as remainder, so we will place 2 on the board. Then we will check for 3. For 3 we will be getting 2 as the remainder. Then we will check 4. 4 is producing 1, so we will place it on the board, right? So this is what we have to do. Now if we check for 5, so it will be producing 0, so this condition won't be satisfied, right? So this is the condition for the first day. After doing procedure on the first day, we have got 5 2 and 4 on the board. Now on the second day we have 5 2 and 4, right? So 5 we have already done, although we have to check for all the numbers, but 5 we have already done, so we'll be getting 2 and 4. If we select 5, let's select 2, right, and check for 2. So this should be 1. We have to place all those numbers on the board. So for 2, if you divide 2 by I, so if you take 1 here, then it will be producing 0. If you take 2, if you take 3 4 5, will not be getting 1 as the remainder, right? So we'll not be placing anything now. Then we'll check for 4. So if we check for 4 modulo I is equal to 1, so for 1 it will not be possible. For 2, for 3 it is possible, so we'll place 3 on the board, right? So 4 modulo 3 is 1. So this is for the second day, right? Then we will move on to the third day. On the third day, what we will be doing is we will be taking all the numbers on the boards. So now 5 2 4 we are already done for them, so we are left with 3, right? So there is no need to check for 5 to 4. We have already checked it, right? So for 3, if you divide 3 by any number, so for 1 it is not possible. For 2, yes, it is possible, right? But 2 is already on the board. For 3 4 5, not possible. So these are the distinct numbers. Now we have to perform this operation for 10 raised power 9 days. We'll be performing this operation for 10 raised power 9 days, right? So that makes no sense to like move further from third day for this test case, right? Because we'll be using these numbers only to produce the result, and we have done that already. So by the third day we have got our answer, right? So we have to only calculate the distinct numbers. So the distinct numbers are 4 in this case. So now if you see the constraint given in the question, n can be from 1 to 100, right? When n is from 1 to 100 and you are performing this operation for 10 raised power n times, like more than n number of times that is given to us in the question, then definitely we'll be getting all the numbers inside of this. But because we have to get modulo 1, because we have to get modulo 1, we will not be getting 1 on the board for any test case, right? Why? Because we, like, 1 will always produce a remainder of 0, so we'll never be getting 1 on the board, right? So for this case, also for all the cases, we'll be getting all the numbers except 1, right? So our answer will be n minus 1, right? So we'll be getting n minus 1 distinct numbers, right? And that is also evident by the fact that you have to take all the 5 numbers and you start from here, right? So if you take this, then with its adjacent number, if you do the modulo, you'll get 1, right? Similarly, now this is on the board, so if you modulo with this, you will get 1. If you modulo 3 with 2, you will get 1 as the remainder. But you cannot do 2 modulo 1 is equal to 1, right? So 1 will not be on the board. So that means all the n minus 1 numbers will be on the board. So n minus 1 will be our answer. But there are two edge cases, that is for 1 and 2. Now let's say our n is 1, right? If our n is 1, we will only be having 1 on the board, right? Now let's say if we have 2, right? Then also we'll be having 1 on the board. Oh, sorry, 2 on the board, but not 1, right? So this is the, for 1, there is an edge case, right? So that is what we have tackled. For 2, it will be still n minus 1 because we will be having 2 on the board at least, right? So basically that's the logic of this problem is. So the code is very simple. If n is 1 or 2, we will simply return 1. And if it is any other number, we will be returning n minus 1 because we will be producing all the numbers, right? Because the days that are given to us are 10 raised to power 9. And we only have n between 1 and 100. So we can easily say that we don't have to perform for 10 raised power 9 days. Like if we are doing something for 10 raised power 9 days, we are considering each and every number. And also it is evident that all the adjacent numbers will produce 1 if we take modulo, except for 2 and 1. Only for this pair we will not be getting. I hope this question is clear to you. Thank you.